we're going to look at the concept of slope of a line. Slope of a line is usually, we call it M, the letter M, and it is the up to over ratio. And some people call it the rise over the run. In this example, if I have this line drawn here, I can get the slope of that line by starting with any point on the line and doing the up to over ratio. So how we would get to the next point. It could either be the point above or it could be the point below. In this particular example, the slope is I would go up 1, 2. So the slope in this case is up 2, positive 2. Then I went right 1 over 1. So the slope of this line is 2. I also could get the slope if I had taken this point and gone to 1 below it. Then I would have gone down 2, which is negative 2. So the slope would be negative 2. And in this case, I had to go left. And left is negative 1. And negative 2 over negative 1 is positive 2. But very often we want the slope not from the graph, where you're not given a graph of a line, but you're given ordered pairs on the line. So let's take a look at 2 ordered pairs on this line. So let's say we look at this point, I'll call it A, which is the point 2, 1, 2, 3, 4, 5, 6. So this is the ordered pair 2, 6. And suppose you were just given that ordered pair, and then you had another point on the line B, and that's the ordered pair negative 2, negative 2. So in this particular case, suppose we didn't have the line and you were just given the point 2, 6, and the other point B is negative 2, negative 2. We would still want to be able to get the slope of that. So some people will remember that the slope of a line is the difference between y coordinates, y2 minus y1, and the difference between x coordinates, going to the same point where you started. If you were just given these points, we could get the slope like this. The slope is 6 minus negative 2, and then you go back to the same x, and that is 2 minus, and then you put the other x value, negative 2. So it's 6 plus 2 is 8, 2 plus 2 is 4, and sure enough, we get the same value just looking at those ordered pairs. But it doesn't matter which is the y value you choose. I chose y2 to be the upper y value, but let's say I have point A, 2, 6, point B was negative 2, negative 2. I can get the slope if I start with the lower y, so it becomes negative 2 minus this y value is 6, and then we go to the same x value in the same point, negative 2 minus the 2, and sure enough, that's negative 2, negative 6 is negative 8, negative 2 minus 2 is negative 4, and that becomes 2. So it is the same slope, just does not matter which of the ordered pairs you start with. So we don't need a graph in order to get slope. So for example, I could say find the slope of the line that connects, and I just give you the ordered pairs. So I could say find the slope of the line connecting the ordered pairs 5, 3 and negative 2, 3. So I want the ordered pair 5, 3 is one of the points on the line, negative 2, 3. Calculating the slope, doing the difference of the y's, it's 3 minus 3 over, going to the same x in the same point, negative 2 minus 5. 3 minus 3 is 0 over negative 7. And we know that 0 in the numerator, 0 divided by anything is 0. So this is a 0 slope. Let's take a look at what this graph of this line would look like. So I'm going to go to the next page and we'll graph it. We'll take a look at what the line would look like. I told you the ordered pairs were 5, 5, 3, and negative 2, 3. We do the ordered pair 5, 3, which is over 5 and up 3. I'll call this point A if you want. And then point B is negative 2. So left 2, up 3, and there's B. So if we put the line connecting those 2 points, we have a horizontal line. So it turns out this one, which has a slope equal to 0, is a horizontal line. And sure enough, because the y value is always 3, the equation of this line is y equals 3. So it's nice to memorize that when the slope is 0, it's a horizontal line, and it's y equals some number k. So that's good. We'll now work another example. Suppose I ask you to get the slope of the line connecting 2 points, and the 2 points now will be 4, negative 1, and 4, 5. We're going to get the slope, and the slope is the difference in the y's. So I'm starting with 5, so it's 5 minus negative 1, and then we go back to the x-coordinate in the same point, 4 minus 4. So this is 5 plus 1, 6 over 0. But we know that when you have 0 in the denominator, it's called an undefined value. So we now have an undefined slope. So we'll go to the next page and we'll graph what this line looks like. So now I'm going to graph. We had the line connecting the point 4, negative 1, and 4, 5. 4, negative 1, we go over to 4, down to this point. Let's call that point A, is 4, negative 1. Then 4, 5, we go over to 4 and up 1, 2, 3, 4, 5. Let's call that B. And sure enough, you can see as we connect this line, we have a vertical line. So it's good to memorize that when the slope, in this case it was 6 over 0, which was undefined, because it's undefined, that tells us it's a vertical line. And in this example, instead of being y equals, it's vertical, x is always 4. So it's the line x equals 4.